Hello, welcome to today's lesson. Today we are looking at the parabola. Now, as usual, let's look at the form of a parabola. Now, we are going to look at the two forms of a parabola. The first one is y equals to ax squared plus bx plus c. So this is a quadratic. So a parabola, it's quadratic. Right, and the other form is y equals to a into x minus p all squared plus q, whereby the p and the q, so the p and the q are actually the coordinates of the turning point. So that's where our graph is going to turn when the equation is in this way. All right, the shape. So we need to understand the shape of the graph. So the shape is like this. If the value of a is positive, so the graph will be like this, and then the graph will be like that if the value of a is negative. Right, so now, unlike other functions, the parabola, it's increasing and decreasing. It is both increasing and decreasing. So it's decreasing, this one, from negative infinity up until the x value here, and then from there it's increasing. Right, this one, it's increasing from negative infinity up until this x value there, and then from there it is decreasing. You can see parabola is both increasing and decreasing. Right, so now we are going to look at how to sketch a parabola. So we looking at how to sketch a parabola graph. So let's take, for example, the function y equals to x squared minus 4x minus 5. So we want to sketch this graph. Right, we're going to calculate two things. Number one, the intercept. Number two, the turning point. So let's start with the intercept. So we start with the y-intercept. We know that the x value is 0. So the graph will intersect the y-axis at negative 5. So that's where the graph will intersect the y-axis. So let's look at the x-intercept. So we know that the y value is 0. So in other words, we will have x squared minus 4x minus 5 is 0. So we can factorize here. This is a trinomial, so we know it's a negative and a positive. Vectors of 5 is 5 and 1, so we'll have a 5 here and 1 there, so giving us x to be 5 or x to be negative 1. So it means our graph will intersect the y-axis, the x-axis at 5 and at negative 1. Right, now we want the turning point where the graph is going to turn. So that's the turning point. We'll just call it TP. So we're going to use the formula x equals to minus b over 2a. Right, this formula, it's from calculus, so it's actually where the graph is turning. Now, just for a background of it, if we have the graph of ax squared plus bx plus c, let's say maybe equals to 0, and if we differentiate this, because if we want the turning point, it's where the derivative is 0, right? So if we differentiate this, we will get 2 times a, which is 2a x, and here we'll have 1 times b, which is plus b, and then the derivative of a constant is 0, so we will have this equals to 0. So then we solve for x, so we will say 2a x equals to minus b, so x equals to, dividing by 2a both sides, it will be minus b over 2a, right? So this is, that's why we are using this formula for the turning point, right? But this, it's something else under calculus. We will see it when we get to that chapter. But then when we want the x coordinate, back to our story, when we want the x coordinate of the turning point, we will just take this formula and use it. So in our equation, we will have x equals to minus b, so we set the b there, it's a negative 4, so in other words, we'll have a negative 4 over 2 times a, which is 1, right? So a negative and a negative is a positive. 4 over 2 times 1 is 2, so 4 over 2 is 2. So in other words, the x coordinate of the turning point is 2. To get the y coordinate, we can just simply substitute into the original equation, which we said it's x squared minus 4x minus 5. So we say we substitute with the 2 there, so it's 4 times 2 minus 5, right? We can just punch our calculators there and we will get a negative 9, right? So it means that our graph will turn, so the turning point will be at 2 and negative 9. Now we know where our graph is going to turn. We have our intercepts. We said that our intercept is 5 and negative 1, and then the y-intercept, we said it's negative 5. So it means we have all the tools that we need to draw our graph. So let's now draw our graph. These are the axes. This is x-axis, this is y-axis, right? So we have 0 there, so our graph is not drawn to scale. So we can start anyway. Let's just start with our turning point. It's at 2, so the x is 2, and then the negative 9, so that's our turning point. So our graph cuts the x-axis at negative 5 and another axis, at negative 1. We said the x-intercepts are 5 and negative 1, so we will have something like, and we said our graph is turning here, so we will have something like that, right? So it's turning at negative 1 and positive 5, and the y-intercept we also said is negative 5. So this is our parabola graph, and that's how we draw it. Remember, we said this is 2, right? Now something that is very important here, the axis of symmetry. Now this line of the x-coordinate of the turning point, it's actually the axis of symmetry. It is dividing our parabola into two equal parts. So it means we can use this fact to our advantage. So if we know that the graph is cutting at 2, and we know that one of the points, like this one, maybe it's 5, because we know that this is the axis of symmetry, this can even help us to get the other point even if we did not have it, because we can simply say, okay, this is the midpoint between the 2 points that were given, because this is the line x equals to 2 is the axis of symmetry. It's our axis of symmetry, so we can use it to get any missing point if it was missing, like if this -1 was not there. So but we have the 5, so we would be able to get it because this is the axis of symmetry. I hope you understand that. Right, so we have seen how we sketch the graph. Now, can we be able to calculate the equation? So remember, this point here is 2 and -9. So that's where the graph is turning. Right, so let's see whether we can be able to calculate the equation of a graph if the graph is drawn for us. Right, so we have two conditions that we are going to look at. Now, the first condition, it's when we are given, remember, we want to calculate the equation of a parabola. We want to calculate the equation of a parabola. So let's check the given information about that graph. So the first condition is when we are given the x-intercepts and one point. So if we are given the x-intercepts and 1 point, then we can be able to calculate the equation of a parabola. So we will use excuse me. So we will use then equation y equals to a into x minus x1 x minus x2. So that's when we are given the x-intercepts. So in other words, the x1 and the x2 are our x-intercepts. So when we are given the x-intercept and 1 point, any point, so we will use this formula. Now let's look at another situation, another condition. It's when we are given the turning point. So when we are given the turning point and one other point, right, so when we are given the turning point and one other point, so in that case we will use the equation y equals to a into x minus p all squared plus q, where the p and the q are the coordinates of the turning point. Right, so we are going to look at an example. Let's say maybe we are having a function. Let me just draw a function here, a parabola. So this parabola, it's okay, let's draw it. Right, and then we have this point here it's -3, and this one it's 1. So right, and maybe we have a point here which it's let's say it's -2 and -6. Right, if we check in this graph here, we are given the x-intercept and one point, a point, let's say the point is A. So we are given the x-intercept and 1 point, and we want the equation of this graph here. So what we're going to do, we're going to use that equation, which we set A into x minus x1 and then x minus x2, where the x1 and the x2 are our x-intercept. So what we're going to do is we're going to substitute the point on the x and the y is the point. So the y value, you can see it's -6. So the y value is -6, and then the A is actually what we are looking for, and then the x value is -2. Now the x-intercept, you can see the first one is -3, so we have a -3. Now remember, it's minus minus, so the 3 itself is negative. All right, so we have the x, which is -2, then minus, and then the x number 2 there is 1. All right, so in this case we will have -2, this will be +3, which is 1. So it's A into 1 times this is -3. So if you look at this, it will give us -3A, and this is -6. Dividing both sides by -3, we get the value of A to be 2. So in other words, A is 2, and then we can put the A to be 2 there, and we get our equation. So we will have the equation as y equals to A, which is 2, into x minus into -3. So we can just say minus 3 is +3, and then we have x minus 1. So this is our equation. We can even remove the brackets. So this x multiplied by x, it's x squared. X multiplied by -1 is -x, and then 3 times x is 3x, and 3 times -1 is -3. Right, removing the brackets, so we will have this 2. Let's just simplify it before we remove these brackets. Minus x and 3x, it's 2x minus 3. Now we can remove the bracket and have 2x squared plus 4x minus 6. Right, so right, there we are. So we saw how to calculate the equation of a parabola when we are given the x-intercepts. So we have the x-intercepts, which is -3 and 1, and any other point. Right, now let's look at the situation where we are given the turning point. I'll just draw another graph, not to scale. So we have this graph here, it's a parabola, and then we are given the turning point here. Let's assume that this is the turning point. Let's say it's 2 and 9, and this graph is cutting here at 5, so it means here is 0 and 5. Right, now we want the equation of this graph. So because we have the turning point and 1 point, so we will use the equation y equals to A into x minus p all squared plus q. Right, I prefer that we substitute the turning point first. So it's A into x minus the p is 2 all squared plus the q, which is 9. Right, and then substitute the other point that is given. So you can see is the point 0 and 5. So the y value is 5, and then the x value is 0 minus 2 all squared plus 9. Right, now we can solve for a. So we can start with the bracket. 0 minus 2 is minus 2 squared is 4. 4 times a is this will give us 4a. The 9 comes to this side. It's going to be 5 minus 9, which is actually negative 4. Right, dividing by 4 both sides, so we will get a negative 1. So it means a is negative 1. So what we're going to do now, we're going to substitute the a there, and we have our equation as y equals to negative 1 into x minus 2 all squared plus 9. Right, so this is our equation, and this is how we find the equation. So we can be able to calculate the equation given these conditions. So we said the first one, if we are given the x-intercepts and 1 point, so in that case we use the graph, the equation y equals to a into x minus x1, x minus x2. So we have seen the example there, and then we work. In both cases we must get the value of a. So substituting, we get a, and then we substitute it back, we have our equation. Right, so the second one is when we are given the turning point and 1 point. So in this case we use the equation y equals to a into x minus p all squared plus q. So we substitute the turning point 2 and 9, and then we substitute the point, which is the y value is 5, the x value is 0. So we are able to calculate the value of a even here, and when we finish we substitute it back and we get our equation. Right, so I take it that now we are able to calculate the equation of a parabola. There may be other conditions that we are given, but these ones are the basic conditions. So as those conditions come, we will deal with those conditions as they come. So I'm just giving the basic conditions that we must know in order to calculate the equation of a parabola. Okay, let's now look at the domain and the range. The domain and range. Right, so we are looking at the domain and the range of a parabola. Right, with the domain, the x values, it can take any value of x as long as it is real. So all values of x do exist on the parabola. So it's very easy. Any parabola, if they want the domain, will just indicate that x is an element of real numbers. Now, but with the range, normally they may not even ask about the domain because there's really nothing to ask here. But with a parabola, the preference of a question is to calculate the range. Now, for the range, it depends on the graph. So if the graph is a decrease function like this one, so we set a is less than 0, it means the range will be y is less or equals to the value of q. Remember, the value of q is the y coordinate. Let me just write this. It's the y coordinate of the turning point. Is the y coordinate of the turning point, not the y-intercept, but the y coordinate of the turning point. So we are going to look at the y value at the turning point. Right, same thing applies if the graph it's an increasing, it holds water. So we know that the a value is greater than 0. So in this case, the range will be y is greater or equals to q. So remember, we said this q is the y coordinate of the turning point. It's the y coordinate of the turning point. Now this has been general. So now let's be practical. Let's calculate the range of the functions that we did above. Right. So the first one, we just look at it. We looked at the first one. Right. So we can even start with the one that we have drawn. So, right. So now looking at this graph here, we realize that the y coordinate of this graph, it's -9, and therefore if we want the range of this graph, we'll simply say, because a is greater than 0, you can see this graph is carrying water, so we will say simply the range will be y is greater or equals to -9. So please don't forget the equals to also, because the -9 is included also. Right. So we are going to look at the range for each of the graphs that we have drawn. Right. Now the second one was this graph here. Right. If we look at this graph here, we want the coordinate, the y coordinate of the turning point. So it means here we have to work it out first. So we go to the equation. Remember the equation, we said it is 2x squared. So the equation is y equals to 2x squared plus 4x minus 6. We want the y coordinate of the turning point, so we will just get the x value first, which we said is minus b over 2a, and then we substitute. B value is 4, 2a is also 2, and then we get a -1. So it means the x value is -1, and then we just put the -1 there. So y will be 2 times a -1 all squared plus 4 times -1, and then minus 6. Right. So we can take our calculator, work this one out, so we can see that it is actually -8. So if we want the range of this graph, we'll just simply say the range, it's y, it's greater or equals to -8. So we set the y coordinate of the turning point. We must remember that. So let's get to the next graph that we did. The last one was this one. Here already we know the point there. We can see the y value is 9 and the graph is facing down. So the range of this one, the range will be y is less or equals to 9. Right, that is how we get the range. So we need to really understand this issue of the domain and the range. So I've summarized it here. If the graph is facing down, then we know that a is negative. The value of a is negative, is less than 0. So the range will be y is less or equals to q. We said that q is the y coordinate of the turning point. But if the graph is facing up, this graph is facing up there, so it means the a is positive. So the range of this graph will be y is greater or equals to q. So remember, the q is the y coordinate of the turning point. The y coordinate of the turning point, not the y-intercept, but the y-coordinate of the turning point. Okay, let's do a little bit of transformation. So we take our graph, we go back to our function. So let's say we have the graph y equals to x squared minus 4x minus 5. We can even change this graph and have minus x squared plus 4x plus 5. Let's say we have this parabola. Now we are going to do reflection, and we are going to do translation on this graph. So let's say we want to shift it. So let's do translation. We want to shift the graph, let's say 2 units down and 1 unit to the right. Let's say we are going 1 unit to the right. Right, so the new graph will be y equals to minus, remember the x is for left and right, and so they're saying 1 unit to the right, so we'll have x. Now we shift it 1 unit, so we can write it first, 1 unit, right, plus 5, and then we said 2 units down. For 2 units down, let's just say minus 2 there, so because it's 2 units down. Right, now we need to remember this. If we shift to the left, we need to add. If we shift to the right, we need to subtract. So here they said we must shift to the right. So when they say shift to the right, we have to subtract. So we'll say minus 1, because they were set 1 unit to the right. So if we simplify this, we can just have minus into x minus 1 all squared plus 4 into x minus 1 then plus 3. So we can even remove these brackets if we want to, but this will be the new graph after shifting it 2 units down and 1 unit to the right. So I want to stress this. If it's on the graph, on the equation, to the left and to the right, so when they say to the left, we must add. Maybe I should write it again. When they say go to the left, you need to add. When they say to the right, you need to subtract. So do not forget this one, because it's very important. But as we have said earlier on, if it's a point, let's say it's point A is 2 and 3, and they are saying shift to the left. So when you shift to the left, just go to the left. Yeah, indeed, you must just subtract. So you just go this side, so just subtract. But if it's an equation, you're doing the opposite. When they say left, you must add. When they say right, you must subtract. Now why? Because if let's say it's x plus 2, you see, if we want the value of x, if we are going to solve, we are going to have a negative 2. You see the plus, now it's a negative, so it has come to the left hand side. But if it was minus, it will be plus and it will come to the right hand side. That is why when we say go to the left, you add, and then go to the right, you subtract. So we need to understand this type of things, so otherwise they will confuse us. Right, so now we look at reflection. Let's go to reflection. Right, so we said we have lines of reflection, so we are looking at the line, the y-axis, we are going to reflect along the y-axis, we are going to reflect along the x-axis, and we are also going to reflect along the line y equals to x. Now remember, the line y equals to x, we are actually calculating the inverse. In this case, we are calculating the inverse. So let's see what is happening. So when we reflect along the y-axis, we just have to know that the x value changes the sign. X changes the sign. X changes the sign, or its sign. So when we reflect along the x-axis, it's now y that changes the sign. So when we reflect along the line y equals to x is the inverse, x and y, x tends to y, y tends to x. So they exchange positions. All right, so let's take the 3 examples. Okay, let's take the one that we had there. So we had y equals to minus x squared plus 4x. So we have minus x squared plus 4x plus 5. Now we are going to reflect it along the y-axis and then along to the x-axis. So let's start with the y-axis. Reflecting along the y-axis. Now remember, y-axis is the same as the equation x equals to 0. So x equals to 0 everywhere on the y-axis. Right, so now we are going to, we said when we reflect along the y-axis, x changes the sign. So in other words, the answer will be y equals to minus, so the x changes the sign, so it becomes minus x all squared plus 4. X changes the sign, it will become minus, and then plus 5. Right, so this is the answer. We can simplify it, so this will be a minus x squared minus 4x plus 5. Right, so this is the reflection along the line y equals to x. I think we should be very careful here. Somebody might be tempted to say this is plus, but remember there are 3 negatives. This is squared here, it's minus x squared, so hence we get a minus. So let's be careful there. All right, so now let's look at the reflection along the x-axis. Remember, we are reflecting, so we reflect along the x-axis. Now remember, in this case y changes the sign, therefore we are going to have minus y. If we look at the same function here, so we will have minus y equals to minus x squared plus 4x plus 5. So y has changed the sign, right? In this case we just multiply by y throughout, so the equation would be y equals to x squared minus 4x minus 5. So we have multiplied everything by negative 1. So that is when we reflect along the x-axis. Right, the next type of reflection we will be along the line y equals to x. So let's say we have, okay, we are now going to reflect along the line y equals to x. So let's say we have an equation, maybe y equals to 2x squared. So we want to reflect the graph y equals to 2x squared along the line y equals to x. So let's not forget that we said the reflection along the line y equals to x is the same as calculating the inverse. It's the same as calculating the inverse, and then the symbol for that we have something like that. So When we see that, we know they are asking about the inverse. This symbol is about the inverse, and the inverse is the same as reflecting along the line y equals to x. So let's remember all these things are correlating, right? And then remember, for the inverse or reflection along the line y equals to x, we are going to exchange the x and y. So here is our equation. Where we see y, we put x. Where we see x, we put y, and then after that we solve for y. So in this case, we'll say x equals to 2, and then now we put y squared. Right, this is our equation, but we need to rewrite it and make y the subject of the formula. So to solve for y here, we can start by dividing by 2. So we have x over 2 equals to y squared, and then we can solve for y. So to get rid of this 2 here, we find the square root. Therefore, our equation will be y equals to, now remember, the square root must be plus or minus, so we have the equation as x over 2. So we will have this type of an equation. Right, now we can even try to draw this graph of the inverse. All right, so this graph of the inverse, maybe it's going to be something like this. Now if you check this now, the inverse of a parabola, you see, if we can draw any line here, a vertical line here, it cuts the y-axis twice. So this inverse is not a function because it has two y values, and it has one x value but two y values. This y value here, whatever it is, and this y value there, whatever it is. So this function, this is actually not a function because it does not pass the vertical line test, or it has two y values, so it's many to one. Right, so the question might come and say, how do we restrict the domain? So how can we restrict the domain so that this inverse becomes a function? So we will simply say, okay, we will just have x is greater than 0, or we have x is less than 0. So we take one part, either this part or we take that part. So then it can be a function. Thank you very much. So please don't forget to like and subscribe. Thank you.